Hi there, and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we will be learning about the transition metals. This is for GCSE chemistry students who are studying the triple science or single science course. And if you do find this video helpful, please feel free to like, comment, and subscribe, and share this with anyone else you think would also benefit from learning more. You can also find me on Instagram and TikTok at the GCSE science teacher for more GCSE support in science. So the question of the day is, what do these images have in common? Well, they all start with the same prefix, which is trans. You have an image there of translocation, which is the movement of dissolved sugars like glucose up and down the stem of a plant through the phloem. You have an image of a transplant, which is happening during surgery. You have an image of transportation, such as cars and buses. You've got the transition of the different seasons, and you also have translation of languages. And essentially, the reason I'm saying this is because trans essentially just means the movement of one thing to another. And it's the same in the transition metals that we see in chemistry. So these metals are all located in what we call D block in the periodic table. If you want to learn more about the periodic table, definitely feel free to check out my channel. I've got a video on it. I'll link it in the cards above. These metals are hyper useful for different things. They all have similar properties, but there are some exceptions to the rule, and I'll talk about that in a moment. But as I say, they are all metals. Most of the elements in the periodic table are actually metals, and this basically means that they're able to form metallic structures or they have metallic bonding. So, therefore, they have delocalized electrons that are able to move freely, and that allows them to conduct electricity. They also have a very shiny structure, which helps them be used for various objects. And some of them are even magnetic. So, iron, for example, is a magnetic transition metal. So, if we compare these transition metals with group one or the alkali metals, we can see that transition metals all have a higher melting point, they have a higher density, or they have more atoms in a given volume of space. They have a greater strength and a greater hardness, which means that they're very useful in objects that have a lot of wear and tear to them. There are some exceptions to this rule, however. So, mercury is an example of an exception. Mercury is a liquid at room temperature. It has a very low melting point, around minus 39 degrees Celsius. There are also other metals in the transition category that are magnetic, like I said. So, we've got iron, we've got cobalt, we have nickel, but some of them are not magnetic, like copper. Copper is often used for creating wires for electrical devices, and that's because of the excellent conductivity that that particular metal has. Something else to mention as well, whenever you get asked in the exam to compare something, you want to say what is different about them, but you also may want to add what is the same about them. But more so is the structure of your sentence, which is why I've written this out like this. I've written transition metals have a higher melting points than alkali metals. That kind of directly compares those sentences, those two individual things, and that's how they like you to write it in the exam. So, when we talk about the periodic table, we cannot prevent ourselves from talking about reactivity. And this is no exception to this topic as well. So, the reactivity of the transition metals is as follows. You need to know how they react with oxygen, with water, and also the halogen. So, let's dive in. In terms of transition metals reacting with the oxygen, we need to know that they form metal oxides. We need to know that this is a very slow process. Often it requires some form of heat being applied. Um, you also may want to compare it to group one. So, group one metals, as we know, are highly reactive and they react a lot faster than, say, transition metals in oxygen. When the transition metals react with water, we can see that this is again very slow. Um, and again, group one metals are much more vigorous in their reactivity with water. And this is because of the atomic structure of those particular metals. I will definitely link that video for you. Um, Something to be aware of, a transition metal such as iron, we actually get hydrated iron oxide, which forms when iron reacts with water. This takes a while, but this is essentially when if we had a piece of iron and we placed it in water, we would see rust starting to form. So anytime you see that orangey substance, that is that rust forming, and that's essentially a chemical reaction where the transition metal iron is exposed to water and some oxygen, and that causes the hydrated iron oxide to form. And that's quite a damaging part of that object because it actually weakens the metal structure as well. So it's not really a good thing, it's rust. Um, we also have the reaction with halogens. And if you are wondering what a halogen is, I will link this video for you. There's a lot of vocabulary in science. I think you might recognize that. So it's always good to refresh our memory. But just so you know, a halogen is a group 7 element. You often find them on the right side of the periodic table. They're non-metals. Okay, so group 1 metals react vigorously with the halogens. However, some transition metals will react with halogens, but some obviously will not as well. So, how do we identify a transition metal? How do we actually find one and know it's a transition metal? Well, there's a few things you can do. So, the first thing you could do, the transition metals will all form ions with different charges. So I've got some examples here. We have copper, which I've mentioned before. We can have a copper plus or a copper 2 plus ion. We've got manganese, which forms a 2 plus ion or a 3 plus ion, depending on how many electrons have been donated. Notice that, however, they are all positive. Remember, metals form positive ions. They're all cations because they are able to donate those electrons, and they do that to become stable. You can also identify a transition metal because of the colored compounds which form. So, metals that are not transition metals will often form colorless compounds, so white compounds. However, if a metal is a transition metal, we will know it is because it forms a colored compound. So, we've got iron 2 hydroxide, it has like a green kind of color. We've got iron 3 hydroxide, which is that orangey color, which is that rust. And iron 3 oxide can also be kind of like a reddish color too. Transition metals, additionally to this, can also be useful as catalysts. And I will talk more about catalysts for chemistry and also biology. Remember, biology talks about catalysts in terms of enzymes. And I'll do videos on this in the future. But transition metals are really useful as catalysts. Essentially, they are able to uh, lower the activation energy and increase the rate of reaction. That's essentially what a catalyst is. And it doesn't get used up. So you can use it throughout different processes and make the reaction very efficient. An example being iron, which is a catalyst in the Haber process to make ammonia. You've got manganese oxide, which is also a catalyst in the decomposition of hydrogen peroxide to oxygen and water. Different types of reactions. And like I say, I will delve into this in another video in the future. But I hope you did find that helpful. If you did, like, comment, and subscribe. Share this with someone you think would also benefit. It's always good to hear from you in the comments and also on TikTok and Instagram. So feel free to follow me on there as well. I've been the GCSE science teacher and you have been curious. Thank you so much for your time. I'll see you in the next one. Bye.